So systems of linear equations, and let me go into the lesson that we're going to be going over. And we are going over section 13 and going over a couple of different sections. The systems of linear equations. This is going to be solving linear equations by hand, and then this is the lab we're going to eventually go over, and this is solving systems of linear equations using Numpy. So as information, this is section 13. And hi, Chris. What are linear equations? In mathematics, a system of linear equations is a collection of two or more linear equations involving the same set of variables. So in this instance right here, we have three equations and we have three unknowns. We have x, y, and z. So we could use linear equations to solve this problem. You always need as many equations as you have unknowns. So in this instance, three equations, three unknowns. If you have just x and y, you just need two equations. The word system in this system of linear equations indicates that the equations are considered collectively rather than individually, and that's important. So let's jump into an example, and we're going to solve this first one by hand, and hopefully we don't regret that. Just because it's easy to kind of mess one of these up by hand. So let's say that we're going to do a problem. We purchase 2 Corvettes and 2 Hummers. We went on a little bit of a bender, and that cost us $240,000. And my markdown looks bad. And then our friend purchased 16 Corvettes and 1 Hummer for $760,000. We want to know how much are the Corvettes. How much is a single Corvette? And a single Hummer. And we are making the assumption here that no one here got any special price on them. We got them for the same price. There wasn't any specials or anything. So in this instance, we have two unknowns, which is one is the price of a Corvette, and the second unknown is the price of a Hummer. And we also have two equations, these 2 Corvettes and 2 Hummers, and 16 Corvettes and 1 Hummer. So we can write 2 equations with this, and I'm going to represent C as Corvettes, so 2C plus 2H equals 240. 1, 2, 3. And then our second equation is going to be 16 Corvettes, 16C, plus 1H equals 760. 1, 2, 3. And sorry. There it is. It looks a little bit better that way. Does anyone have any questions up to this point, how I got these 2 equations? Nope. Good deal. So now, next step is I need to solve for one of these variables in one of these equations. And I'm going to solve for Hummer in the second equation, just because there's a 1 next to it. It'll be a little bit easier to solve for it. So to solve for this equation, I'm going to subtract 16C from both sides of the equal sign. So I'll have 1H equals $760,000 minus 16C. And then dividing by 1 on each side just to get rid of that 1 will obviously not change the equation at all. So I'm left with H equals 760,000 to 3 minus 16C. So I have this equation right here, and I will use this equation to plug into this first equation. And that is going to look like 2C plus 2 times $760,000 minus 16C equals 240. 1, 2, 3. So we are there. Now I'm going to multiply this 2 into this into the parentheses here. So 2C plus, I should have definitely used smaller numbers. 760,000 to 3 times 2 is 1.552 million. Yeah, definitely should have used smaller numbers. 1.520, 123 minus 32C equals 240. 1, 2, 3. So 3 zeros. Does this make sense so far? No problems? It's easy to make a mistake on this, so if you guys see anything funny, definitely let me know. Now I'm gonna simplify like terms. So I have a 2C, I have a negative 32C here. So 2C minus 32C is negative 30C plus 100, 1, 5, 2, 0, 1, 2, 3 equals 240,000. And finally, I'm going to move this 1.52 million over on this side. So I have a minus 30C equals 240,000. And it equals negative 1.28 million. So now I can solve for C. C equals 1.28 million divided by 30. And that gets me 42,666. 42,600. I'll round to the nearest whole number. So it's 42,667. Does that make sense? Is that what everyone else got?
Yeah.
All right. So I have this price of a Corvette, 42,667. I can plug this back into one of my equations and get the price of a Hummer. And I'm going to plug it into, I'll plug it into the second equation, this one right here. And the price of a Corvette is 42,667. And I'll multiply it out right now, save a little bit of time. 42,667 times 16. And this equals 682,672. plus 1h equals 760,000. One more zero. And then I'm going to subtract 682,000 on both sides. That will leave me with h equals that will leave you with h equals 77,328. All right, so the price according to these linear equations, the price of a Corvette is 42,667, and the price of a Hummer is 77,328. So that is your system of linear equations. Looks like I got a chat. Sorry. Oh, all right. All right. So I got a problem for you guys now. Hope everyone has a. Do you have a calculator or on a? Yep, got it. I saw that pen you have. Perfect. All right. So you buy 2 apples and 4 carrots, and you buy 2 apples and 4 carrots for $1,328,000,000. I'm just joking. $10.
There's better be some damn good carrots.
Yeah. And then your friend buys 11 apples and 2 carrots for $23. And I bought them from the same place, same day. So the price did not change. So how much are apples and carrots? Oh, man. And give that a try. Are you still working, Chris and Costa and John?
Yeah.
Okay. No worries.
Sorry, I wasn't working on this exact example. I was just kind of following along with what was going on.
Okay.
I mean, you guys can keep go ahead.
Yeah. Are you pretty close, Chris?
Yeah.
Okay, well, we can give you a couple more minutes. This is kind of tedious work, and I think just 2 equations is about the maximum that I will do by hand. You get into 3 equations, it's too much.
Boy, it shows your perseverance.
Now, linear systems of linear equations is, I don't know, it's really crazy what you can solve with these, and it's kind of crazy to think about like all these like AI bots are basically being solved by systems of linear equations under the hood by thousands and thousands of them.
That's why math is so fun. You can model anything. Well,
Mm-hmm. Yeah.
Sure. Okay.
All right. You got it figured out? Did you get the answer, Chris?
Yeah. I
Right.
think so. We keep going.
Okay.
Yeah.
What do you get, John?
I got, X is apples, so apples is $1.80, and then carrots are $1.60.
All right. That sounds right. So I'm not going to do another one by hand. I'm going to do this. We're going to solve this using Numpy this time, using matrix operations, and we can have some fun with that. So here is the equation, and to represent it in Numpy, you'll use three matrices: a matrix with your left side of your equation, a matrix with your right side of your equation, and then a matrix with your variables. A and C are apples and carrots. And then you can represent it like this. And dang it. Sorry, let me correct something real quick. There's not supposed to be those asterisks in there. Oh, there we go. And so you can represent it like this, where you're taking a dot product of this matrix C times the dot product of this matrix C will get these values. And so you have these matrices right here. And unfortunately, in matrix operations, you can't divide. So you'll have to take the inverse. So multiplying a matrix by the inverse of the matrix is essentially, in matrix operation, is division. So this operation, and we'll prove it out, is equal to 1. And so X is the inverse of A times B. So let's import Numpy and test it out. Import Numpy as NP, and then A equals np.matrix. And I want 2x4. 11 by 2. And I forgot my outside brackets. So let's take a look at it just to make sure it looks right. Yeah, 2 by 4, 11 by 2. And then my B matrix is np.matrix. And 10 by 23.
You got a bracket.
Missing open bracket there.
Yeah, thank you. I was going to say, what is this list doing in here?
The open bracket before the 23.
Okay, yeah. There it is. Thank you, guys. So I got it. This looks good so far. And so now I'm going to calculate the inverse of the matrix. I want inverse, yep. And I want to take the inverse of the A matrix. And so if I multiply this A matrix times this A matrix, the inverse of the A matrix times the A matrix, I'm going to get what is known as an identity matrix. And that will look like, and that's where you'll have ones going across the diagonal. And when you multiply an identity matrix by anything, it just equals, it's essentially multiplying by 1. So this A inverse times A, this essential part right here is essentially 1. So this is why you can cancel this part out, and it equals X equals A inverse times B. So let's calculate out A inverse times B times B. And we get that 1.8, which is apples, and carrots is 1.6, which I believe that's what you said, John. So great job. And so this was, we kind of went through this. There is an easier way of doing this, of course. Linear algebra, and it is solve, yeah. And this way you can just put in the two matrices, and it'll calculate the, solve it out for you. So 1.8 and 1.6. So cool stuff. So like I said earlier, solving, you can solve two variables by hand by doing 4. I think, John, you're pretty quick. I don't know if you could do this do you think you could do this in half an hour?
Am I allowed to use linear algebra or not? Or is it no?
Yeah. Yeah, so yeah, this problem would take me several hours to try to calculate by hand. But with Numpy, it's pretty quick. NP matrix. Let's try and do it real quick. So 2, 4, 5, 6, 11, 2, 4, 3, 8, 3, 5, 9, 11, 3, 6, 11. And the B equals NP matrix. $45 and then 78. And yeah, so we solved it out, and yeah, these are pretty nasty numbers to calculate too. So yeah, that's how you do it with Numpy. Does anyone have any questions so far? Not too bad. Definitely, it's good to have a little bit of an understanding of what's going on under the hood, but I usually would recommend just doing this method right here. Now, John, you're a math guy, so you like the challenge, right?
Yeah, of course. I mean, if you don't know how to break it yourself, then I mean, yeah.
All right. So yeah, I'm going to go through this solving the systems of linear equations with Numpy lab. And um, and Chris, do you mind if I put you on mute? There's a little bit of hear a little bit of feedback.
Yeah. Yeah. Sorry. Yeah. Go ahead.
Yeah, no worries. Okay. So the objectives of this lab: build a system of equations from given problems by creating matrix and vertices in Numpy. Calculate the inverse and dot product to get the values for unknown variables, and then solve linear equations using numpy.linearalgebra.solve. So first, I always write out the equations just because it's easy to make mistakes. So on this one, a coffee shop is having a sale on coffee and tea. On day one, 29 bags of coffee and 41 bags of tea were sold, giving a total of $490. On day two, they sold 23 bags of coffee and 41 bags of tea, for which customers paid a total of $448. So equation one is 29, I'm going to say C for coffee plus 41 bags of tea equals $490. Equation two equals 23 bags of coffee plus 41 bags of tea equals 448. I thought the equations were exactly the same for a minute. That's why I froze. I was like, this isn't good. But yeah, 29 plus 41 equals 490, and 23 plus 41 equals 448. So let's make our matrices. Use numpy.matrix. Oh, import numpy. That's why tab complete isn't working. np.matrix, there it goes. And I want 29 plus 41 and 23 and 41. And 23 and 41 need outside brackets. What am I doing? I'm completely messing up. So this B matrix is my the right side of the equation. 490 and 448. And NP dot.
Should B be in two different rows, I guess?
Yeah, good call. That's gonna, because it's gonna take a dot product, and let's just do it like this. It's gonna throw an error because they're different sizes. Yeah. Oh, well, it's gonna throw it. Let's try it this way. Yeah, yeah. So a mismatch on the size of the dot product. So what I could do is do this B dot transpose. We'll get it, but let's just verify it. Make sure it is. It should be the same. Oh, let's get rid of the transpose. Yeah, 7 by 7, 7 and 7. So cool. But good catch there. So explain your answers in terms of price. So coffee is $7 and tea is $7. And yeah, I'm not going to mess around with the markdown because the dollar signs are messing with me.
Okay, Jeff, it's okay.
Yeah. Yeah, dollar signs and markdown, that usually the start of latex, I believe.
It is, and I can't remember how to not make it like that.
Yeah. Yeah. Just make it regular comments is the solution for in this case. But yeah, I should probably look that up. Does anyone have any questions at this point? And you may have noticed I'm using this matrix method. When you use the matrix method, it is going to take, when you do a multiplication, it's going to do a dot product, not just a regular multiplication. If I did np.array, it's going to try and multiply them instead of taking dot products of them. So you'll have to, if you can use np.array, but you'll just have to be careful you use the dot product. All right. Exercise number 2, the cost of admission to a popular musical concert was $162 for 12 children and 3 adults. The admission was $122 for 8 children and 3 adults in another musical concert. And this is assuming that the price for each of the musical concerts was the same for children and adults. So how much was admission for each child and adult? I'm going to write it out again. So 8 children plus 3 adults equals 122. And I'm doing the second equation first for some reason. I'll do the first equation now. So 12 children and 3 adults equals $162. And yeah, let's make our A and our B matrix. So 8 and 3 and 12 and 3. And 122 and 162. So it was $10 for children and $14 for adults. And kind of making it pretty easy with this linear algebra.solve. Let's do a inverse, calculate that, and then multiply that by the B. Fun. So we remember this equation. So A inverse times B. We'll do it that way, just for some added fun. And I believe it's in linear algebra, and yeah, inverse. And it's the same. And this is the process I was talking about earlier, where if these were in Numpy arrays, this would have to be I'd have to use np dot, the dot product instead of just regular multiplication. So just be careful when you're doing that. Let's try that out real quick. I want to make it regular Numpy arrays so you can see that. So 8 and 3 and 12 and 3 and B equals np.array. And 122 and 162. I'm going to name these A1 and B1 just because I want to look at A versus A1, which is the Numpy array. So this is a matrix, this is a Numpy array. And let's first I want to try this out right here because I'm not sure if this is going to work. I think it will still. A1 and B1. That still works, but where'd it go? This process will change because it's NumPy arrays. A1 inverse equals np.linearalgebra.inverse A1. Now, if I just did the exact same process I did, it's going to throw an error, at least it should. Or, yeah, it doesn't throw an error, it just multiplies them together. Just does regular matrix multiplication. So I want to do, what was it, np dot. And there it is, 10 and 14. So again, describe your results. Tickets for adults are $10 and tickets for children are 14. Cool. So we are on to equation number 3, or question number 3. You want to make a certain kind of tropical punch using bananas, oranges, and papayas. Suppose you don't know how many of each to put in the punch, but you know that there are 7 pieces of fruit in the mix. And there are twice as many oranges as bananas, and you also know that the 7 pieces of fruit cost $5.25, where bananas cost 50 cents, oranges cost 75, and papayas cost 125. How many bananas, oranges, and papayas would you need to make this punch? This is definitely like a high school math question where you have to first decipher what the equations are. So suppose you don't know how many of each fruit to put in the punch, but you know there are 7 pieces of fruit in the mix. So there are that first equation, we can use this to make our first equation. So we know bananas plus oranges plus papayas equals 7 in total. And because there's 3 unknowns, we need 2 more equations. There are twice as many oranges as bananas. So bananas equals 2O. They're twice as, no, other way around. So oranges equals 2B. Is that right? Oranges, so there are twice as many oranges as bananas. So oranges equals 2 times B. I think that is right, unless someone has some differing opinion.
I think you're good. I think you're good.
Okay, thanks.
Word problem.
And we also know that the we also know that the 7 pieces of fruit cost $5.25. So we know that bananas times 0.5, so 0.5B plus 0.750 plus 1.25P equals 5.25. And I'm going to simplify this equation out because that's not in a form that I can put it in a matrix right now. So it's going to be, I'm going to put everything on the left side of the equation. So it'll be negative 2B plus oranges plus 0 papayas equals 0. So now I have these 3 equations and 3 unknowns. I'll delete that one. So A equals np.matrix. And equation 1 is this guy right here. So 1, 1, 1. Equation 2 is this one right here. So negative 2, 1, and 0. Equation 3 is this one right here. 0.5, 1.75 and 1.25. B equals 7, 0, 5.25. So linear algebra dot solve. Nice, comes out really even. Bananas are $2, oranges are $4, and papayas are $1.
Quantity.
Okay, yeah. Very good. Good catch, good catch.
There we go.
I was saying that, and I was like, I thought I already knew the price. But that makes a lot more sense. So we have 2 bananas, 4 oranges, and 1 papaya. Great job, John.
You're doing all the work, Jeff. I mean,
No, you're the brains behind the operation, I think. So question number 4. Costa and Chris, do you have any questions or anything so far? Make sense?
Yeah, everything's making sense. So thank you for
Yeah.
checking in.
Good deal. Chris, I'm sorry, I can unmute you if you. Maybe I can't unmute you. If you have any questions, Chris, definitely feel free to reach out. And I don't know if you have it on mute on your side anymore, but looks like I cannot unmute you. But we're going to move on to this question number 4. This is the last one in this lab. A landlord owns 3 houses, a 1-bedroom house, a 2-bedroom house, and a 3-bedroom house. The total rent he receives is $1,240. He needs to make some repairs where it costs 10% of the 1-bedroom house. 10% of the 1-bedroom house's rent for its repairs, 20% of the 2-bedrooms house for its repairs, and 30% of the 3-bedroom house's rents for its repairs. And the total repair bill for all 3 houses was $276. The 3-bedrooms house is twice the 1-bedroom house's rent. And all right, so we got to write some equations again. All right, so we have 3 unknowns, so we need to decipher 3 equations from what they gave us. So let's start at the top right here. This looks like it should be an equation. So what variable should I use for this? So 1, 2, and 3. I'm going to do A, B, and C for 1, 2, and 3. So A plus B plus C. A equals 3-bedroom. A equals 1 bedroom. B equals 2-bedroom. And C equals 3-bedroom. A plus B plus C, these 3 houses that this guy owns or girl owns, and he makes or she makes $1,240. He needs to make some repairs where it costs 10% of the 1-bedroom house, so 0.1, and the 1-bedroom house is A, plus 20% of the 2-bedroom house, 0.2, plus B, plus, and then 30% of the 3-bedroom house, and the total repair was $276. And then, so 2 equations. Last equation is this right here. So the 1-bedroom is twice the rent of the 3-bedroom house. So that would be A equals 2c. And I'm going to put this in a form that I can use for my matrix. So I'm going to move everything to the left side again. A plus 0b minus 2c equals 0. And I'm going to make my A and my B matrix again. And B dot matrix 1, 1, 1. 0.1, 0.2, 0.3, and 1, 0, -2. My B matrix is 1240, 276, and 0.
Are you sure that third equation's right? A equals 2c. The 3-bedroom house is twice the 1 bedrooms, right?
Yeah. What do you?
That's what I'm asking.
So the 2 times the. Oh yeah, I got my. It should be.
Vice versa, right?
Yeah, 2a equals c, right?
Right, because A is 1 bedroom, and no matter what.
Yeah.
Well,
I was just making sure I got my second equation right. I was thinking I got that wrong now.
no. I mean, the second one looks good, I think.
Okay. Yeah, but I definitely mixed up the variables on this one. So 2 times the 1-bedroom house equals the 3-bedroom house. That makes sense. Here, 2 times the 3-bedroom house equals the 1-bedroom house. It's got to be a pretty nice 1-bedroom house.
All the amenities, rent's included. I mean, it's a pretty nice.
It's a pretty nice house. So I got to change this equation. So again, I'm going to move everything on the left side of the equal sign. So 2a equals 0b minus c. And then that would be -1. So the rent for the, again, 1-bedroom house is $280. Rent for the 2-bedroom house is $400, and for the 3-bedroom place is $560. So nicely done. So that's why I was never very good at like multiple choice questions on math questions growing up, because like I feel like the math teachers would like put that other option where it would be A equals 2C, this result, on the multiple choice.
Yeah.
As like a, but it should be 2A. I don't want to confuse anybody.
No, they're just mean at that point. They're just trying
to. But hopefully, this would have given a result where the 1-bedroom house was would have given a result that the 1-bedroom house was more expensive than the 3-bedroom house, and hopefully that would have been a red flag when if you're doing a multiple choice test that maybe should look back. But yeah, that's all that I have on solving system of linear equations. Any questions or comments? All right. Yeah. If you guys have any questions, kind of going back, definitely feel free to reach out.
Seems very straightforward. I mean, I haven't used much of these methods yet, but it's more about building the matrix than anything else.
Mm-hmm. Yeah, I think on these problems, it was just kind of it was kind of like going back to old word problems back in high school. Was yeah, building the matrix, writing out the equations were kind of the more challenging part. Than and Numpy was always doing all the heavy lifting for you.
It's just one line. Just tell it to solve, and it does it.
Yeah, yeah. It's still good to kind of have an idea of what is going on under the scenes, where it's taking the inverse of your A and doing a dot product with your B matrix. But all right, well, yeah, I'll have this recording. Should be up tomorrow or so if anyone wants to look at it wants to watch it a second time. Otherwise, have a great rest of the night, and yeah, talk to you guys tomorrow.
Yeah. Thank you, Jeff.
Yeah,
Thanks,
no
Jeff.
problem. See you later, guys.
Gotcha.